Centrality analysis of crime network. As the data available to the secret agencies increases, so does the pressure for them to use the data in efficient ways to prevent crimes increases. If we have information about who all people are going to do some criminal activity, then by plotting the connections on graphs and by centrality analysis, we can stop the criminal act. The following 4 types of centrality will help us in this task. 1 degree centrality. 2 closeness centrality. 3 betweenness centrality. 4 eigenvector centrality. Degree centrality measurement helps us to know about people who have most direct connections. Degree of a node in an undirected graph is simply the know of edges that are connected to that particular node. Here each person represents a node in the graph. Degree centrality analysis for a graph is shown below. Here we see that Poron has the highest degree centrality score. Hence, he has the maximum number of direct connections. Closeness centrality. Closeness centrality analysis determines the importance of each individual based on how many middlemen are required to reach all the other individuals in the network. If there are n nodes in a graph, then for a node I the closeness centrality is calculated as AI is the number of reachable nodes from node I, not counting I. N is the number of nodes in graph. Closeness centrality analysis for a graph is shown below. From graph we see that Martha has the highest closeness centrality value, which means she requires least number of middlemen to connect with other people of the group. Betweenness centrality. Betweenness centrality analysis highlights the individuals closest to a high flow of activity. By identifying a person with a high betweenness centrality, we can see who controls the flow of information in the network. These nodes people could be particularly interesting to disrupt, as arresting the most effective criminal could slow down the activity of the entire crime network. Node with higher betweenness centrality would have more control over the network, because more information will pass through that node. Betweenness centrality is related to a network's connectivity, in so much as high betweenness vertices have the potential to disconnect graphs if removed, that is, cut vertex. Betweenness centrality for a node U is calculated as NST of U is the number of shortest paths from S to T that pass through node U. NST is the total number of shortest paths from S to T. Betweenness centrality analysis for a graph is shown below. From graph we see that Martha has the highest betweenness score. Hence arresting her could slow down the activity of the entire crime network. Eigenvector centrality. All the previous centralities give all connections equal weight. They would weigh connections among peers the same as connections to leadership. But in reality it isn't so. Some connections are more influential than others. Eigenvector centrality analysis determines the importance of each node based on the importance of its connections. Eigenvector centrality can be calculated by power iteration method, whose explanation is given in attached PDF. Eigenvector centrality scores are shown for a graph below. From graph we see that Poron has the highest eigenvector centrality score, hence he has maximum number of influential connection. For this case the node having highest eigenvector centrality is also having the highest degree centrality score. But it is not always true, it may not be followed for some other graph. Thus, here we saw that how graphs and centrality analysis helps us to find the key people involved in the attack, and we can stop the attack using it. For the 9/11 attack, same theory was used to catch Muhammad Atta, one of the ringleaders of the 9/11 attack. Graphically it is shown below. Commercialization. Graph theory and centrality analysis aren't only used in this field, but they are also used to tackle problem of cybercrime on Facebook and Twitter. Including concept of machine learning, a model can be prepared and launched in real market, which will be very useful to decrease crime. A recent study by Deloitte and the Financial Services Information Sharing and Analysis Center found that financial services on average spend 10% of their IT budgets on cybersecurity. Microsoft CEO Satya Nadella recently revealed in a statement that the tech behemoth will invest more than $1 billion each year in cybersecurity for the foreseeable future. 2019 U.S. President's budget allocated $15 billion in spending on cybersecurity. This shows the importance of graph and discrete mathematics in our real life. Geographic profiling. Let's first understand what we meant by term geographic profiling. Geographic profiling is an investigative support technique that analyzes the locations of a connected series of crimes to determine the most probable area of criminals' residence. It's also important to stress that geographic profiling doesn't solve cases. What it does is help manage the large volume of information typically generated in major crime investigations. As we have seen how geographic profiling helps us by looking at series of crimes and their sites, about criminals' likely residence. But how to compute such things? So let's get a view on its mathematical interpretation. Rosmo formula. Rosmo's formula is a geographic profiling formula to predict where a serial criminal lives. The formula was developed and patented by criminologist Kim Rosmo and integrated into a specialized crime analysis software product called Rigel. The Rigel product is developed by the software company Environmental Criminology Research Incorporated, ECRI, which Rosmo co-founded. So now let's just get familiar with Rosmo formula. Let's understand its each variable. Parameters F, G and B are to be determined by backtesting the formula on local crimes. By doing this, you can calibrate the formula to your local area. And calculating this for every crime site will give an hot zone which will not be too far away from all the crime sites and also not so near to any crime site. And now plotting this probability on 3D model will give us an overview of the criminal's most probable location. Not exact. Now let's look at one of its real-life application. This is the 2D plot obtained after applying Rosmo formula on a map, which was used to find criminal Richard Trenton Chase of California, US. Let's understand this plot. Green color describes actual crime site. Yellow color describes buffer zone in which there is likely the residence of criminal. Blue color describes the complementary part to criminal's residence. Red color describes criminal's probability for his or her residence's maximum. Purple color describes criminal's actual residence found by police. Estimating time of death. Newton's law of cooling states that the rate of cooling of an object is proportional to the temperature difference between the object and its surroundings, provided that this difference is not too large. When estimating the time of death, one needs to know the temperature of the surroundings and the temperature of the body at two different times in order to make an accurate estimate. It is assumed that the temperature of the body Tt is governed by Newton's law of cooling. Where K is a negative constant, T is the ambient temperature, and time T is the number of hours since the time of death. Also, the temperature of a human body at the time of death is considered to be 98.6 F. T0 equals forensics use of Newton's equation. The formula used in forensics looks like this. Where Glater is the temperature of the body at the second reading. Disk is initial temperature when the body was discovered. K is cooling constant. Tam is the ambient temperature of the room, surroundings. Delta T is the time difference between the first and the second temperature readings. Solve for T. Substitute in the variable depth for T and substitute the variable depth for Glater. Assume that the value of K equals 0.132647814. Do not round this number and the body temperature at the time of discovery was 90.4 F with the surrounding temp 68 F. Find the time since death. As per following formula. This number will let you know how many minutes or hours ago the person died. Quiz question. In a murder investigation, a corpse was found by a detective at exactly 8 p.m. Being alert, the detective also measured the body temperature and found it to be 70 degrees Fahrenheit. 2 hours later, the detective measured the body temperature again and found it to be 60 degrees Fahrenheit. If the room temperature is 50 degrees Fahrenheit, and assuming that the body temperature of the person before death was 98.6 degrees Fahrenheit, at what time did the murder occur? A. 7:30 p.m. B. 6:30 p.m. C. 5:30 p.m. D. 4:30 p.m. Pause the video for 3 to 4 minutes and solve the question. Hope you have easily solved this question. Its simple application of Newton's law of cooling and answer to this question is C. i.e. murder occurs at 5:30 p.m. Team Vro. Thanks for watching. Like and share.